here we go. We are starting Unit 8, which is all about rational expressions. And essentially, rational just means that we're talking about a fraction. So instead of just a number on the top and the bottom of the fraction, we have polynomials. So we're stepping up our fraction game. Basically, the rule of the unit that we are going to keep coming back to again and again and again is to factor first. Whenever it's possible to, you want to try to factor. So we already did some reviewing of factoring, and that is definitely going to come up all throughout Unit 8. So we factor first whenever possible. Okay. One thing to note, and we'll see this right away with example 1, is that monomials cannot be factored. So a monomial, remember, is something that is just one term. So a monomial cannot be factored. Okay, so we are asked to simplify each of these expressions. And what we want to do is we want to look for a common factor. So 10 over 6. Can I simplify 10 over 6? You bet I can. That is just 5 over 3. And then I look at my x's, and we just talked about how when we divide powers, we subtract the exponents. And there are more x's on the top than there are on the bottom. So we're left with 5x to the 4th over 3. We couldn't factor anything there because those were both monomials. Okay, let's try number 2. Are these things that we can factor? Yes, they are. They are trinomials. So I am going to set up my fraction, and I'm going to factor the top, x squared plus x minus 2. So we have x and x. The only way to get 2 is to do 1 and 2, and then I got to figure out, okay, how can I get a positive 1? Well, the way to do that is a plus 2 and a minus 1. All right, let's factor the bottom. Very similar process. So I'm going to have x and x. To get 3, the only way to get 3 is 1 and 3. To get a 2x in the middle, I'm going to have a plus 2 and a minus 1. And now, once we have it factored, we can easily see that we have a common factor on both the top and the bottom. So we're going to cancel out what's in common on the top and the bottom. And my final simplified answer would be x plus 2 over x plus 3. Now, something that I see a lot is students will say, oh, look, the top and the bottom both have an x. Now I can cancel those out. Do not do that. The only reason that we can cancel these out is because everything is connected by multiplication. Okay, so here's an important note. You can only cancel when connected by multiplication. So in this instance, the x's are not connected to the 2 and the 3 by multiplication. It would be different if, here, let me get a little sticky note here. Let's say I had 2x over 3x. Then I could cancel out the x's and just be left with 2 over 3. But in this case, since it's connected by addition, not multiplication, we have to leave this as is. Okay, examples 3 and 4 are going to be similar. So let's take a look. Are these things that we can factor? Yes, in fact, they are. 4x plus x squared. So this isn't a trinomial like the bottom or both of the polynomials in number 2. However, these two terms have a common factor. They have a common factor of x. If I take x out of both of these terms, if I take x out of this, I'm just left with 4. If I take an x away from x squared, I would be left with x. And remember, the way you can check it is to see, okay, if I went back through and distributed that x, would I be left with what I started with? And the answer here in this case is yes. All right, on the bottom, x squared plus 2x minus 8. So I'm going to have x and x, and I need to have something that multiplies to negative 8 and adds to 2. So that is 4 and 2 with a plus 4 and a minus 2. Now look, everything is connected by multiplication. This x is being multiplied to this factor here, and these two factors are being multiplied together. So I'm allowed to cancel something out that's in common on both the top and the bottom. And in this case, we have x plus 4 and 4 plus x, which are the same thing. So see ya, wouldn't want to be ya. All right, this simplifies to x over x minus 2. And that's my answer. All right, I would like you to pause the video and try number 4 on your own. So pause the video, go through number 4, see how you're doing with this. All right, hopefully you were able to factor both the top and the bottom and find that they both have a common factor of x minus 3, and we're left with x over x plus 4. All right, we reviewed how to add, subtract, multiply, and divide fractions. So guess what? We can multiply fractions that have polynomials in them, just like we would multiply regular fractions. So like, for example, if I had 2/3 times 6/5. When I'm multiplying fractions together, we simply multiply straight across. And once I have multiplied across, I'm going to say, okay, can I simplify this at all? Is there a common factor? And yes, there is. I can take out a factor of 2, and we would be left with, what am I thinking? 3 times 5 is 15. Okay, let's try this again. So 2 times 6 is 12, 3 times 5 is 15. 12 and 15 are both divisible by 3, which gives us 4/5. Okay, so we're going to do a similar thing here, except hopefully I won't make any more silly mistakes like that. So let's multiply across. These are monomials. I cannot factor this at all, so we're just going to go ahead and multiply across. 3 times 10 gives me 30. X to the 5th times x cubed is going to give me x to the 8th because we add exponents. Y cubed times y to the 4th gives me y to the 7th over 2 times 9 is 18. X cubed times x squared is x to the 5th. Y to the 7th times y to the 5th gives me y to the 12th. And once I've multiplied across, I'm going to see if I can simplify. So 30 over 18, anything I can divide both 30 and 18 by? Yes, I can divide them both by 6. So 30 divided by 6 is 5. 18 divided by 6 is 3. Now I look at the x's. Are there more x's on the top or on the bottom? In this case, we have x cubed on the top. And for the y's, we have more y's on the bottom. So we have y to the 5th. And that would be our simplified answer there. Okay, number 6. Our rule of the unit is to factor first whenever possible. So let's check everything. X minus 3, nothing I can do with that. X plus 5, same thing here. 4x plus 20. It doesn't look like it at first glance. However, I can take out a common factor of 4. X squared minus 9. Can I factor this one? Yes, this is a difference of squares. Difference of squares is going to come up a lot this unit. So you need to get comfortable with recognizing difference of squares and how to factor it. X squared minus 9 factors into x minus 3 and x plus 3. Okay, so I'm going to multiply these together. Multiply straight across. So I have x minus 3 times x plus 5. And then on the bottom, I have 4 times x plus 5 times x minus 3 times x plus 3. Everything is connected by multiplication, so I can go ahead and cancel out anything that both the top and the bottom have in common. So I see a factor of x plus 5, and I see a factor of x minus 3. So when everything cancels out, that means there's really just a 1 there. So I'm going to have 4 times x plus 3 because that's the only thing that's left. And that would be my answer. All right, let's keep moving. Oh, I skipped the line at the bottom. What does it say? You can also divide rational expressions. So recall, to divide a fraction, you multiply by its reciprocal. So let's say I had 2/3 divided by, 4/5. So 2/3 divided by 4/5 would mean that I'm going to do 2/3 times 5/4. And then it's just a multiplication problem again. So that would give me 10 over, let's see if I can multiply correctly this time. 3 times 4 is 12. And then I got to see if I can simplify, which I can. We get 5/6. So we're going to apply the same process to our polynomial fractions. It's going to be the same thing. Okay. So first thing to do is to turn the division problem into a multiplication problem. And I'm going to check, can I factor anything? No, because these are all monomials. So this is going to become 5x to the 4th over 8x squared y squared times, and then I flip this, 8y to the 5th over 15. Now I'm going to multiply across. 5 times 8 gives me 40, and then I just have x to the 4th, y to the 5th over 8 times 15 is, let me think here. 80 and 40 is 120. And then we have x squared, y squared. Okay, 40 over 120 is the same thing as 4/12, which is 1/3. So I'm just going to have a 3 on the bottom. I could put a 1 here, which I will, I guess. 1/3. Then I look at my x's. Okay, more x's on the top and more y's on the top. So, and I'm just going to rewrite this because I don't know why it bothers me if it's not in the center. It looks funny to me. So this is really just x squared y cubed over 3. Okay. So let's see what we got going on here. This is a division problem. But I also can factor all of these things. So let's see here. I have a common factor in this one. This is x squared times x squared minus 9 over, let's see here. How can I factor this? That's going to give me x and x, and I need something that multiplies to 3 and adds to -4. -1 and -3. Times, I have to flip this, right? I have to flip this now. So my denominator is going to go on top. X squared minus 16 is difference of squares. So that's x plus 4 and x minus 4. And then here, what do I have? I have a common factor of x squared that I can take out, which leaves me with x squared plus 2x minus 8. Now, I'm actually not done because there's still more that can be factored. X squared minus 9 is a difference of squares, and this also can be factored. So I'm left with x plus 3 and x minus 3 over x minus 1 times x minus 3 times x plus 4 and x minus 4 over, I still have that x squared there. And to factor that, I'm going to have x plus 4 and x minus 2. Now, everything is connected by multiplication, and I can cancel out whatever's on the top and the bottom. So x squareds go away, x minus 3's go away, x plus 4's go away, and I think that's it. So my final answer is x plus 3 times x minus 4 over x minus 1 times x minus 2. Okay. Complex fractions. A complex fraction is basically when you have a fraction inside of another fraction. So like if you look at number 9, there's our big fraction line, but then in both the numerator and the denominator, it's a fraction itself. But what you have to remember is that a fraction just means that we are dividing. Okay, so to simplify complex fractions, treat it like a division problem, because that's exactly what it is. So this is going to be x plus 2 over x minus 1 times the reciprocal of this. So now I'm going to have x minus 3 on the bottom. And the other thing I'm going to do is I'm going to factor this, because that's the rule of the unit. We factor whenever possible. Cancel out what's in common. We get x plus 2 times x plus 5 over x minus 3. All right, let's try one more. I'm going to rewrite this as a multiplication problem and factor along the way if I can. X squared minus x has a common factor of x times, I'm going to flip this, so x is on the top. X squared minus 9 is a difference of squares, x plus 3, x minus 3. And now let's see what I can cancel out. X plus 3 and 3 plus x are the same thing. Then I have x and x. Nothing is left on the top, so I just put a 1 there. And then on the bottom, I have x minus 1 and x minus 3. Okay. Solve. Check your solution. So what we're going to do is we are going to simplify. And to do that, we are going to factor, because that's the first thing we do whenever possible. X squared minus 25 is a difference of squares. And when you factor it, you suddenly realize that, hey, I can cancel that out. And now my equation is much simpler. Subtract 5 from both sides, you get x equals 9. All right, I would like you to pause the video and try number 12 on your own. Ready, go. All right, so you can factor the top. Those x minus 2's are going to cancel out. That leaves you with x plus 5 equals 7. So x equals 2. That is it for lesson 8.2. We'll see you for the next video.